You know that the ether is being hidden via disinformation because it's a nuclear secret and maybe even for more nefarious reasons. But I'd like for you to entertain another interesting idea. What if there was some ancient advanced civilization that once had a good grasp and understanding of the ether? Wouldn't the CIA and all of those people who are trying to hide the ether also need to hide the existence of a breadcrumb trail that could lead to that same information? So that made me interested in what's called the Younger Dryas impact theory, where basically there's this idea that maybe what ended the last ice age is that some huge comet or meteorite or something came down on the North American ice sheet, and then all over the planet there's this dark layer rich in platinum, that where all of the megafauna fossils just butt up against it and stop, and then you don't see anything above it. But the biggest problem that they run into is this trying to find where's the impact site. So one of the main explanations is that, well, the Laurentide ice sheet over North America is 2 miles thick. 2 miles thick. So it's just, the idea is, well, maybe it just hit and then, it didn't leave a mark. However, I'd like to show you something very interesting, something that has been hidden in plain sight. You've seen it a million times, and you're going to love this. Now, you're looking at this map, and you're thinking I'm about to zoom in. I'm not. Look right here. What do you see right in this area? That is called the Nestapica Arc. Now, you're already probably starting to have some thoughts. Here it is on maps whenever they're talking about the Nestapica Arc, and you have the Belcher Islands right there in the middle. And that's what they look like. The obvious bunching and twisting of the Belcher Islands here and these other signs of metamorphosis are blamed on what's called isostatic rebound. That's just the term that means that an effect where after the weight of the glacial ice stops pushing it down, the land raises back up, but nowhere else on Earth is it this extreme. And then, oh yeah, look, notice this nice little curve right here as well, this little edge that's all the way around it too. Now, it should be obvious this looks like a crater. This looks like an impact. But the information that they give you is that, oh, well, it doesn't have these certain things that an impact normally has, and so therefore we're just going to say it's a coincidence, just some random geological feature. But having a 2-mile thick barrier of ice to cushion the blow wouldn't create shock quartz and all of the various features that a normal impact would. It's like a giant meteor struck a protective layer of ice and then stretched the Earth out and then underneath it, and then it just bunched back up, right? That's what it looks like. Pretty obviously. If it did that, it would leave stretch marks that expose deep rock layers and then push them to the surface, as one of your expectation. Well, let's see. Let's see, where are the oldest rocks on the planet found? Right here. It's called the Nevagitic Greenstone Belt, and those are 4 billion years old. And they're right there along the Nestapica Arc. Well, wouldn't the water be almost instantly vaporized and it caused like kind of an explosion, like a steam explosion if it hit? So just like a raindrop, wouldn't pieces be blasted straight up and then rain back down on the unprotected landscape after it, the initial impact melted away the ice? Well, then what would we look for? Gee, I don't know, maybe at the bottom of the Hudson Bay, we'd see a bunch of little meteorite strikes. Huh. What do you know about that? Here's a survey of the Hudson Bay with lots of what look like a bunch of meteorite strikes. Just a bunch of little ones all over the Hudson Bay. But some of you will know that theoretically we should be looking for numerous strikes, because if it's supposed to be all over the planet, then we should at least see some signs of it elsewhere, right? Well, look right here at this interesting feature. Now, I'm not saying that this is necessarily a meteorite strike, but what if big giant chunks were blasted out and those chunks landed on top of other ice and did the same thing again, where it just sort of dented the planet because it had a protective sheet of ice. And look at the angle that this is pointing. Maybe off a little bit, but the Earth does spin, and that will change the angle that things coming from one part of the Earth to the other would strike at. So that's another thing. And then let's go to the next area. There's something called the Hiawatha crater. And here, let's look up here at it. And we find underneath the ice here is another impact crater. And for a long period of time, people believed that this crater was the Younger Dryas impact crater. But recently, there have been some questions about it. They say, oh, well, we measured the argon in the rocks, and that tells us that it's probably older. And so we've changed our opinion about that. Well, that's interesting. So let's continue. And here we are at an interesting little structure in Mauritania called the Richat structure that a YouTuber has done a lot of independent research and given a lot of great evidence that this is perhaps the site of ancient Atlantis. And just nearby, we find another crater. And this crater has been dated right during that exact same time period at the end of the Younger Dryas. And in that paper, where they date it differently than some of the other nearby craters that they've found, and say, no, this one is definitely younger, they point out that something that can happen is that you never get rid of the old argon necessarily. And so therefore, sometimes you can have a crater that appears to be much older than it actually is. And so right here in this crater, that one of the ways that they separated it from the others is that they found that there was additional platinum. They also point out how sometimes you can get the wrong reading from an argon test. So what I'm saying is the Hiawatha crater, the Tanomer crater, and the Nastapica arc may all be part of that Younger Dryas boundary layer impact that brought about the end of some ancient advanced civilization. I think it's very interesting, and I think that there's a lot more to investigate here.